Okay, now in this video, I'm going to show you how to create a voice that makes use of the filter module, and I'll also introduce some filter modulation with an ADSR as well as an LFO here. All right, so we're going to start from scratch, though I already have the USB MIDI connection set up. So we're going to need two pieces of information from this MIDI world. We need that 1 volt per octave signal, or the pitch information, and the gate signal. So as we know, CV1 will output the pitch information. So I'll take a patch cable and connect that to CV1. And then this can go into the 1 volt per octave input on the Z3000. If I was using this oscillator, I'd plug it into FM2 or FM3 and crank up this knob to the maximum, the exponential version. But let's just use the Z3000 for this patch. All right, so let's take an output from the Z3000, a waveform output, and plug it into the filter. I'll take the pulse out and plug that into audio 1 on the MMF. I set the gain of audio 1 to 5 or 12 o'clock. Now I'll take the output from MMF1 and plug it into the VCA. And then finally, the output of the VCA can go into the monitoring system. I'm using the mults. All right, now we need to control the VCA. So I'm going to use the gate output here, plug it into the gate input on one of these ADSRs, and then I'll take the output of the ADSR and plug it into the CV input on the VCA. On the VCA, the gain is all the way down, but the CV amount is set at 5. All right, so this is our basic patch. Let's have a listen to what this sounds like. It's a pulse wave, and we know we can adjust the pulse width here. Oh, sorry, that's the fine-tune control. The one below that is the pulse width. So in the center, it's a square wave. All right, now let's talk about the filter. So currently the mode is set all the way to low pass mode. So if I bring this cutoff knob all the way down, we're going to hear the upper frequencies of the sound get attenuated. We can introduce some resonance, though it's labeled Q peak here on this MMF1. All right, now I'd like to modulate that filter cutoff with a modulator. The simplest one would just be to use an LFO. We can use a VC LFO. So I'll take the sine wave output of the VC LFO and plug it into the modulation input for the cutoff. And we have that labeled CV1 and CV2. Now we're not going to hear any modulation yet, because even though I have made the connection, there is a CV amount knob here for CV1. So we have this cutoff modulation set up, but the amount is set all the way to the lowest. So let's increase this. Leave it at 5, and now when I play a note, you can hear the modulation. If I want that modulation to be more dramatic, I can increase the CV amount. And we get a more exaggerated version of that. All right, I'll leave it at 5. We could change the rate of modulation by changing the frequency on the LFO. All right, so we now have some modulation on that filter cutoff. Now I'd like to simultaneously also modulate the filter cutoff with another modulator. Let's use a second ADSR here. Thankfully, this filter has 2 inputs to modulate the filter cutoff. So we can just plug in a signal on the second input there. So I'll take the output out of the second ADSR here and plug that into the second modulation input on the filter. I'll set the modulation amount to 5. Now, as we know, ADSRs do need a gate signal to trigger them, but this ADSR is such where the first gate will trigger all the ADSRs. And we know that's working because the LEDs light up on all 4 of the ADSRs. So let me shape this ADSR. We're in medium mode here. Now to really hear that modulation, I've brought down the cutoff CV1 knob so we don't hear the LFO modulation anymore, so we can focus on CV2 instead. So you can hear every time I play a note, the filter cutoff opens up and closes back down. Now let's bring in the LFO as well. Alright, so that's the patch. We have multiple modulators, specifically the LFO and an ADSR, modulating the filter cutoff on this patch.